Okay, so far in this unit we've talked about a few things. The slope-intercept form, y equals mx plus b. You can identify the slope and the y-intercept from the equation itself. The slope and the y-intercept. And you can draw your graph right away using the equation. Starting with the y-intercept on the y-axis, and then get a point on the graph using the slope. That's what we did in lesson 7.1. Then, last time, we spent some time on the general form. So general that you don't get to see the slope and the y-intercept unless you do a small calculation. You will still be able to get your slope by using the equation negative a over b. Using the number in front of x and in front of your b, you can then bring those two numbers together and give us the slope. Of course, you can find the x-intercept and the y-intercept as well, but rather than creating a formula, you can make a substitution. If you want to find the x-intercept, you can substitute 0 for y and solve for the x-intercept. Or if you want to find the y-intercept, you can then substitute 0 for x and you solve your equation that way. But negative a over b, that would be the most useful equation for the general form. There is a third form in grade 10. It is called the slope point form. When you are working with a line, besides the slope, which you definitely want to find right away, if you are given a random point on your graph, any random point on your graph, you would then be able to combine the point here, the coordinate of your point, with the slope together and create an equation. But how do they do it? It basically came from the slope formula. In the previous chapter, we've learned how to calculate the slope between 2 points. If you have 2 points on your graph, x1, y1, and x2, y2, you will be able to calculate the slope between the 2 points. You can use y2 minus y1 over x2 minus x1, or you can switch it up and have y1 minus y2 and then x1 minus x2. You can calculate the slope that way. But there are times when they don't give us 2 points. They may give us the slope already, and they will give us one of the 2 points for now. That means we don't have the coordinates for the second point. If we don't know the coordinate of the second point, so that is now gone, we will still be able to come up with something similar to the slope formula. As you substitute the slope into the equation, so here starting with the slope formula, if you have this number, and if you have the first point, the coordinates of the first point, you will now end up with an equation with these 3 numbers. But we don't have the second point. We don't have the numbers for the second point, which is fine because when we are working with line equation, they will always come with x and y as part of the equation. We won't have a number for x and y in those equations. Your line equation will often come with x and y as part of the equation. So it is okay to leave it that way. if you can substitute the slope given to us and the xy coordinates from the point, if you can substitute these three numbers into your equation, it will still give us a line equation similar to what we have seen in lesson 1 and lesson 2. Once you multiply this denominator to the other side, this denominator, once you multiply it to the other side, we will end up with an equation like this. And on the provincial exam, the data booklet given to you will have your equation written in this form, which is basically a switch up between the left and the right side. So every time when you are given the slope at a point, you can use the slope point form to write the equation. You don't have to start with your slope-intercept form. You can start with the slope point form. It depends on whether they give us the y-intercept or they give us a point. If they give us a point and a slope, we will use this equation to start our work. So here in example number 1, right away if they give us a point and a slope, I can always start these questions with the equation here. This equation will be given to you on the provincial exam and on my quest. You don't need to remember this, but you need to know how to make use of it. If they give us the coordinates, x and y coordinates of a point, and if they give us the slope, we will then substitute the slope here and substitute the x coordinate there, the y coordinate there. So it will turn into y minus -4 equals 2 times x minus 3. That will be the equation in slope point form. But when you take a look at this equation, it comes with a bracket. We can get rid of the bracket by using the distributive property. As you open up your bracket, we can now put all the terms to the same side and make it into the general form. Let me put it this way. Let me keep the 2x on the right hand side, and by bringing the y to the other side, it becomes a minus y, and then minus 10. This would then be the general form. Starting with the 2x minus 6 on the right hand side, if I see a positive y on the left hand side, bring it to the other side, put it in between the x and the constant term. The plus 4 on the left hand side, combine it with the minus 6, that will give us minus 10. So this will be the equation in general form. But I can also obtain the slope-intercept form from here. The slope-intercept form will have the y on its own. So I will keep the y on the left-hand side by bringing this to the other side. The plus 4, when you bring it to the right-hand side, it becomes minus 10. So that will be the equation in slope-intercept form. And as you can see, we are still getting the same slope as given to us. We have 2x minus 10. The 2 here in this equation give us the slope. And this time, we have obtained the y-intercept.